In this episode, we're going to make virtualization management feel less like a pile of unfamiliar names and more like a clear chain of responsibility that you can reason through under exam pressure. Many beginners learn that Linux can run a virtual machine, VM, and they learn that there are multiple components involved, but they are not sure which component is responsible for which part of the system. That uncertainty turns simple questions into stressful guessing, especially when a prompt mentions libvirt and virsh as if you are supposed to already know what they do. The goal here is a mental model, not a memorized command set, because Linux Plus is typically testing whether you understand what these tools manage and how that management is organized. By the end, you should be able to hear the words libvirt and virsh and immediately place them in a bigger picture that includes hosts, hypervisors, virtual hardware definitions, and lifecycle operations like start, stop, and migrate. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good first step is to understand that virtualization on Linux usually involves at least 3 layers. The underlying virtualization capability in the kernel and hardware, the virtual machine process that runs the guest, and the management layer that defines and controls those guests. Beginners sometimes focus only on the middle layer, the running VM itself, because that is the visible thing you interact with, but the management layer is where most of the operational logic lives. The management layer is what decides that a VM should exist, what resources it should have, which disk image it should use, and which network it should attach to. That layer also provides a stable way to control VM lifecycle across reboots, because it stores definitions that can be restarted and managed later. Without a management layer, you could still run virtualization in a very direct way, but it would feel fragile and inconsistent because every VM would be created ad hoc. Linux Plus questions that include libvirt are usually pointing to that management layer, because it is the part that turns virtualization into something you can administer reliably. Libvirt is best understood as a management framework and service boundary that provides a consistent way to define and control virtualized resources. Instead of thinking of it as a single tool you type, think of it as a system that offers an interface for managing virtual machines, networks, and storage pools in a standardized way. That standardized interface matters because the underlying virtualization engine can vary, and different systems might use different hypervisor backends, yet administrators want a consistent management experience. In practice, libvirt often runs as a service on the host and maintains a set of definitions for guests and related resources, allowing you to query state, apply changes, and control lifecycles without dealing directly with the low-level details of the hypervisor process. A beginner misconception is believing libvirt is the hypervisor itself, but the more accurate view is that libvirt manages and talks to a hypervisor backend on your behalf. Once you separate management from execution, many confusing exam scenarios become simple classification problems. Another key part of the libvirt mental model is that it manages objects rather than one-off actions, and that object thinking helps you interpret what a question is really asking. A VM is an object with a persistent definition, including its virtual CPU count, memory allocation, disk attachments, and network interface settings. A virtual network is an object too, representing how guests can communicate and how address assignment and isolation may be handled. Storage pools and volumes can also be treated as managed objects, representing collections of images and their allocation patterns. The value of libvirt is that it makes these objects discoverable and controllable through a consistent management layer, rather than forcing you to remember where every configuration file lives or how each hypervisor expects options. For a beginner, the most practical takeaway is that libvirt is about declarative definition plus lifecycle control, not about one specific virtualization brand. When Linux Plus questions talk about managing, listing, defining, or querying virtual resources, they are often implicitly pointing toward this object-based management idea. Virsh is easiest to understand as a command-line client that speaks to libvirt, allowing a human to query and control the objects libvirt manages. Beginners sometimes treat virsh as if it directly manipulates the hypervisor by itself, But a more accurate picture is that virsh is a remote control and libvirt is the controller that actually has authority over the managed resources. This separation matters because it explains why virsh can manage virtual machines even when the underlying execution process is different, and it also explains why the same control concepts can apply locally or to a remote host if configured. The exam framing often uses virsh as a clue that the question is about libvirt-managed domains, because virsh tends to operate in terms of domains, networks, and storage pools that are defined in libvirt's world. The important mental move is to translate virsh into a phrase like libvirt control interface, which immediately reminds you that there is a management service underneath. When you do that translation, the question becomes less about memorizing syntax and more about understanding the management boundary. A useful term that often appears in this context is domain, which is commonly used to represent a virtual machine instance in libvirt's management model. Even if you do not memorize every label, it helps to recognize that management systems often use their own vocabulary to describe the objects they control. A domain is essentially the definition and runtime state of a VM as seen by libvirt, and that includes both persistent configuration and current status, such as whether it is running. The fact that libvirt has a stable object model means you can ask questions like what domains exist, which are active, and what their definitions look like, without needing to hunt through scattered files. This also helps explain a common beginner confusion about the difference between a defined guest and a running guest, because libvirt can store a definition even when the guest is not currently executing. In exam questions, wording like defined but not running versus running but not persistent is a clue that the tester wants you to understand the difference between configuration state and runtime state. The domain model gives you a clean way to reason about that distinction. Once you have the object model in mind, you can understand what these tools manage at a practical level, starting with lifecycle operations. Lifecycle management includes creating a guest definition, starting the guest, stopping it, and controlling whether it automatically starts under certain conditions. It also includes observing state, such as whether a guest is running, paused, or shut down, and whether it has errors related to its resources. The deeper point is that lifecycle control is not the same as guest administration, because libvirt and virsh primarily manage the host-side existence and resources of the VM, not the internal configuration of the guest operating system. Beginners can misread this and assume that virtualization management tools configure the guest's users or packages, but those are separate concerns handled inside the guest. Linux Plus questions often test this separation by describing a problem that is actually inside the guest, such as a service not running, and contrasting it with a host-side management concern, such as the guest not starting. If you know what libvirt manages, you know whether the issue is likely host-side lifecycle or guest-side configuration. Beyond simple start and stop thinking, libvirt also manages the definitions of virtual hardware attachments, and this is an area where exam questions can become subtle. The VM definition includes which virtual disk is attached, what bus type it uses, and what the virtual network interface looks like, among other settings. These details matter because changing them can affect performance, compatibility, and reachability, and they often determine whether a guest can boot or access its data correctly. A beginner might think the disk image is the VM, but the disk image must be attached properly through the definition for the VM to use it. Similarly, a guest might be running, but if its network interface is attached to a different virtual network than expected, connectivity can fail even though the guest appears healthy. The management model is that these are properties of the domain definition, which means they are host-level configuration choices expressed through libvirt. If an exam scenario suggests that a guest has the right disk file but still cannot boot, or that a guest is running but cannot communicate, the definition and its attachments are often the missing link. Storage management under libvirt is another area where the mental model saves you from confusion, because virtualization storage is not just one file, it is a set of managed resources. Storage pools represent where images live and how they are allocated, while volumes represent the individual storage units that guests can attach to. Thinking in pools and volumes helps you understand how a host can organize many guest storage without treating every disk image as a random file scattered across the file system. It also clarifies lifecycle actions like creating a new guest disk, cloning an existing disk, or managing capacity growth, because those actions belong to the storage object model rather than to the guest itself. Beginners sometimes assume that storage operations are purely file operations, but in managed virtualization environments, storage resources are tracked and referenced through definitions to keep relationships consistent. Linux Plus questions that mention managing images, allocating storage, or dealing with a host running out of space are often inviting you to think about how storage is organized and referenced. The practical takeaway is that libvirt provides a structured way to manage storage backing for guests, which reduces accidental misconfiguration. Virtual networking is also part of what libvirt can manage, an understanding that keeps you from treating VM networking as purely a guest setting. A guest can have a network interface inside its operating system, but the existence and attachment of that interface is defined at the host management layer. Libvirt can define virtual networks that provide patterns like isolated guest-to-guest communication, outbound access through a host gateway, or bridged access that puts guests onto the same network segment as the host. The details of how this is implemented can vary by setup, but the exam-relevant concept is that the network mode and attachment are host-side configuration choices that shape reachability. This also explains why migrating a VM between hosts can break networking if the destination host does not have the same network definitions available. Beginners often blame the guest operating system first when a VM loses connectivity, but sometimes the host-side network object is missing or different, which makes the guest interface appear connected but not functional. A strong mental model is that libvirt manages the virtual plumbing and the guest configures how it uses that plumbing. Now let's address how Linux Plus questions frame these tools, because test writers often build questions around roles rather than around raw tool usage. A typical pattern is that the question describes a virtualization task, like identifying which guests are defined, determining which are running, or understanding why a guest does not start after reboot, and it includes a hint that the host uses libvirt. The key is that libvirt implies a managed definition store and a management interface, so you should think in terms of domains and persistent definitions rather than one-off processes. Another pattern is that a question mentions virsh specifically, which is a strong clue that the expected reasoning is about interacting with the libvirt object model rather than with the guest operating system. In those cases, the right answer is usually about listing, querying, or controlling virtualization objects at the host level, not about editing guest configuration files. The exam also likes to test the difference between what is configured at the host level and what is configured inside the guest, because that difference is central to avoiding wasted effort. If you can classify the problem as host-side management versus guest-side behavior, you can often eliminate wrong choices quickly. It is also common for exam questions to probe your understanding of what is persistent versus what is transient in virtualization. A transient guest might be a running instance that was launched without being saved as a persistent definition, which means it can disappear after a reboot because the management layer does not have a stored configuration to recreate it. A persistent guest has a stored definition and can be restarted consistently because the management system knows it exists even when it is off. Beginners often do not realize that a VM can be running without being properly defined for persistence, and they are surprised when it is missing after a host restart. The libvirt model naturally supports persistent definitions, which is why libvirt is used in environments where stable management matters. In a question, if the scenario suggests that a VM was running but is now missing from the expected list after restart, the test writer may be checking whether you understand the distinction between runtime existence and stored definition. This is another place where the mental model of objects and definitions pays off, because it gives you a vocabulary to reason about persistence without getting lost in implementation details. Troubleshooting questions also tend to be framed around the idea that libvirt and virsh are windows into state, not just tools for making changes. Being able to query state is crucial because virtualization problems often involve mismatches between what you think is defined and what is actually active. A VM might appear to be running, but it might not have the expected resources attached, or it might be paused due to resource contention, or it might be blocked by host-level constraints. The management layer can typically report meaningful status, including whether a domain is active, what its configuration looks like, and what resources it references. Beginners sometimes rush to modify settings without first confirming current state, which adds confusion and can make problems harder to diagnose. Exam writers often reward the student who thinks in terms of verify state first, then decide what change is needed, because that reflects mature troubleshooting. The mental model here is that libvirt is a state authority for virtualization objects, and virsh is a way to interrogate that authority. One of the most important beginner misunderstandings to clear up is the idea that virtualization management tools are only for servers, while desktop tools are something else entirely. The truth is that the concepts of defining a guest, attaching storage, selecting network presentation, and controlling lifecycle exist in both contexts, even if the interface looks different. libvirt provides a consistent framework for those concepts, which is why it appears across many Linux environments and is worth understanding at a conceptual level. Another misunderstanding is treating libvirt as an extra layer you can ignore, when in fact it is often the layer that holds the truth about what guests exist and how they are configured. If you bypass the management layer, you may create situations where guests run but are not tracked in a persistent and manageable way. That leads to lifecycle surprises, especially around reboots and migrations, which are exactly the scenarios Linux Plus questions like to describe. The correction is to treat management as a core part of virtualization, not as optional decoration. By the end of this lesson, you should be able to explain libvirt as a management framework that defines and controls virtualization objects like domains, networks, and storage resources, acting as a stable authority that sits above the execution layer. You should be able to explain virsh as a command line interface that talks to libvirt, so you can query and control those objects without directly interacting with the underlying hypervisor process. You should also be able to recognize how Linux Plus questions use these terms to signal what kind of reasoning they expect, often pushing you toward host-side lifecycle and configuration thinking rather than guest-side administration. When you see a scenario about listing guests, confirming whether a guest is running, ensuring persistence across reboots, or understanding why migration or networking behaves differently, you can map it to the libvirt object model and respond with confidence. The mental model is the real skill. Management layer defines and tracks, execution layer runs, and the guest operating system operates inside that environment. Once that story is clear in your mind, virtualization management stops feeling like trivia and starts feeling like a predictable system you can reason about calmly.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.